sound like church hymn whenever that comes on. Guys, please listen. Next class we'll do practice on train, product, and quotient. Okay? Next class I'm going to devote that to that. And maybe towards the end of next class I can introduce the next thing. Okay, briefly. Now, the next set of stuff are easy now. After this, when we get to derivative of maybe trigonometric function, exponential, logarithmic, it's just to tell you when you see E, this is how you differentiate. Every other thing here follow. So if that exponential function comes in form of chain rule, you apply the chain rule. If it is a product, you apply product rule. So that is why these are the big rules. Okay, the rest are just small babies. There is no time, I know, but I needed to finish this, so I'm going to start it. Then I want you to finish it yourself. Again, just if you have quotient of two functions, quotient means division. So the quotient of 20 over 4 is 5. That is the result when you divide. So when two functions are divided, you get another function, right? So basically our rational function that we learned in topic 2. If y is in that format, we use what we call the quotient rule. So you call the numerator u and denominator v. You differentiate them just like product rule. Then you apply this product quotient rule formula. Next lesson we can derive this since it's going to be fully practiced. I can show you how all this is derived. Let's just work on how to use it first. So this is why I said v should come first. So it's consistent. The only difference is there's a minus and there's a division by v squared. V du dx, u dv dx, everything divided by v squared. That's why I want you to start that with a v. So you are used to v being the first one. Then for quotient, you know it is going to be minus, and you still have to divide by v squared. How that is derived, we'll look at it next time. So quickly. So u here will be x, and v will be 1 minus 2x. Du dx, I can write like this. It's 1. dv dx is what? Negative 2. Agree? That's all you need to start with. From dy dx is equal to v du dx minus u dv dx, everything all over v squared. It means dy dx is equal to, what is my v? Quickly. 1 minus 2x multiplying what? 1. Then there's no need for that bracket is redundant. Then u x. There's no need for bracket again. X. Then what is dv? What? Negative 2. Sorry, I know you can't see it. Can you see? This times 1. This times that. Everything over v squared, which is 1 minus 2x all squared. Can you see that? Here, there's nothing to factorize, unlike that product rule example. So if there's nothing to factorize, you expand it. That is, of course, if it is simple expansion, or like this. So this will be 1 minus 2x plus what? And everything over 1 minus 2x squared. So your dy by dx is simply that. But the question never said dy by dx, right? But we interpreted it as dy by dx. The question says, find the gradient of the tangent to this curve at x is equal to 1. It means that curve, you draw a tangent, what is that gradient? So what do we do here? We just substitute at x is equal to 1. This is the gradient function of the tangent. At x is equal to 1, dy by dx will be 1 minus 2 times 1, right? And that is simply 1 over negative 1, right? And that is just 1. Another notation, if you don't want to write all this at x is equal to 1, I've seen some of you work on Zoom, and there's a way you write at x is equal to 1. If you don't want to do all that, all this here, I can say, which implies that dy dx, then you draw a vertical line, you say x is equal to 1. What you are saying is, at x is equal to 1, dy by dx is equal to, so this notation is allowed. Then you can write this. So everything I've written here, I can write like this. So what this means is dy by dx at x is equal to 1. So if you don't want to write English stuff, you can write in math language, it's allowed. Not because I'm against English language, of course. But I prefer my math language. Thank you so much. Sorry for the extra time again.